In trust level plane 0, a zero trust network has been compromised and someone is exfiltrating files. Your task is to identify which files. Launch the challenge and review the provided details. You learn there is a sensitive web server within the zero trust environment. Someone breached that environment and exfiltrated Steal, exchanges, fingerprints, and accounts files. An important detail to help focus your investigation is that only one of each file has been exfiltrated. You will need to identify the 3-digit number of each file to answer the challenge questions. Launch the Kali workstation and connect to the web server. There are 4 buttons on the main page whose labels correspond with the files. Briefly examine the contents of each file type. The Steal files appear to contain a recipe for making steel. The exchanges files appear to be correspondence. The fingerprints files are PNG images with lines, and the accounts files contain account information. With a rough idea of the contents of each file type, you can begin your investigation. This environment contains a Security Onion appliance. Security Onion is an open-source threat hunting, network monitoring, and log management appliance that will help you gain visibility into the environment. Connect to the Security Onion console by using the provided credentials and then click on PCAP, an abbreviation for packet capture. Currently, there are no packet captures available. Click on the plus sign. The sensor ID is Security Onion, and the time range should reflect the date you are completing this challenge. Click on Add. After a brief moment, the status of the packet capture will show complete. Click on the binocular icon to open it. While Security Onion provides some functionality for packet analysis, a dedicated packet analyzer, such as Wireshark, provides additional tools for packet analysis. To open the packet capture in Wireshark, download it from Security Onion, then simply click on the packet capture to open it. Reviewing packet by packet is not efficient, and you do not have additional details about how the data was exfiltrated to narrow your search. As a starting point, review what connections are being made. Go to Statistics, then Conversations. Reviewing the IP version 4 tab, you can see connections taking place within the environment, but also 3 connections going to outside networks. There is also one connection to a broadcast address, which is unexpected behavior. Further investigation is necessary of these 4 IP addresses. By using a filter, you can focus on the 3 external IP addresses. In the filtered results, there are packets for ICMP, DNS, and NTP network traffic. Examining the ICMP packet, notice that Wireshark is reporting it has an incorrect checksum. Examining the packet data, it is in plain text and appears consistent with the Steal recipe you reviewed earlier. 4 ICMP packets were sent in close timing to each other. Clicking on the remaining 3 packets, notice the recipe appears to continue. On each packet, right-click on Data and select Export Packet Bytes and save it as raw data. From the command line, use the cat command to combine the files to form the complete recipe. The challenge question asks you to identify the 3-digit number of the file that was exfiltrated. There are several ways to compare files. You could visually compare, but that would take quite a while given the number of files and would be prone to human error. You could download the files from the server and use a search tool, such as grep, to search for keywords. But with a recipe, there are very few unique keywords that could help you narrow your search. Another option is to use hashes to compare the files. With a shell script and the curl command, download every Steal file to the Kali workstation for examination. In order to connect to the web server, you will need to capture your cookie. An easy way to do this is by using the Inspect tool in the web browser. Select the Network tab and then click on the Steal button. Look for the 200 GET request to /Steal in the Network tab. Right-click and then copy as CURL to use in your script. Create an MD5 hash of the exfiltrated Steal file you recovered, and then compare it against the MD5 hashes of the downloaded Steal files. The file that matches will be the file that was exfiltrated, and the 3-digit number of the file name will be the answer to challenge question 1. Returning to Wireshark, continue examining the other network connections to external IP addresses. DNS queries are being sent to an IP address, which is not a common public DNS server. Wireshark is also reporting that the DNS packet is malformed. Examining one of the packets, the DNS queries are looking for a subdomain of legit.site. The subdomain being queried seems odd, and each query is to a different subdomain. When viewed together, this looks like it could be base64. One application incorporated into SecurityOnion is CyberChef, which is a utility for simple coding and decoding. Copy the subdomains being queried and paste them together as a long string. Copy this into the input section of CyberChef. Under Favorites, select from base64 and drag it into the recipe area. The rendered output looks like the accounts files you examined previously. Follow the same steps from question 1 to download all of the accounts files and use hashes to identify the exfiltrated file number. Returning to Wireshark, continue examining the other network connections to external IP addresses. NTP stands for Network Time Protocol. It is an internet protocol used to synchronize a computer's clock with a time source. Researching the external IP address, this is not a known NTP server. Looking at the packet data, the timestamps and stratum are also incorrect. Looking at the packet data, it appears to be hexadecimal. You can view this entire conversation by following the UDP stream. Copy this data and paste it into CyberChef, and create a recipe to convert from hexadecimal. The recipe output generated is plain text, and matches the exchange files that you had examined previously. Examining the file content, the start time appears to be specific and may be useful for identifying the exfiltrated file. Follow the same steps from question 1 to download all of the exchange files. Use grep to search the files for the date and time to identify the exfiltrated file 3-digit number. Returning to Wireshark, clear the current IP address filter and search for the broadcast IP address. Examining the traffic, the destination UDP port is 12345, which is not a commonly used port. Examining the UDP stream, it appears consistent chunks of data are being sent, with the final packet being smaller than the others. Follow the UDP stream and save the packet data as raw data. Identify the type of file by using the file command, which reports it as a zlib compressed data file. The Kali workstation does not currently have zlib installed, but you can install it using apt. Decompress the file and examine the raw output. The content appears to be base64. Load the decompressed file into CyberChef and select the from base64 recipe. In the output, notice the file header for a PNG file. Save the output as a PNG file and confirm the image matches the fingerprints files you had examined previously. Follow the same steps from question 1 to download all of the fingerprints files and use hashes to identify the exfiltrated file 3-digit number. Enter each identified file number into the corresponding challenge question and click Submit to complete the challenge. This challenge is designed to exfiltrate different files each time, so your answers may differ from what is being shown here. Congratulations on completing the Trust Level Plane Zero challenge.